Hi everyone. So today I'm going to be talking about gravitational potential energy. Essentially, gravitational potential energy is the energy that's stored in objects with respect to their height and due to the ground. So, and as the name suggests, it's potential energy. So it's not something that's kinetic and dynamic and you get it right away. It means that it's stored in objects, and if there is a way for them to spend that energy, they will. For example, if a rock is up on top of a mountain, with respect to the ground, it has some height of like h whatever meters it is, then there will be a potential energy stored in this object because of its height. We already know the higher the rock is, the more potential energy it has. For example, if I have an enemy down here and want to kill this guy, the higher I bring the rock, the easier the rock hits, basically kills this person. Also, I know the bigger the rock, the easier this is going to get killed. So thinking about height and the mass and the weight essentially of the object, it's an educated guess of me, guessing that gravitational potential energy should be related to the mass times gravity, which is the weight of the object times the height. So the more the height, the more energy, more potential energy stored in my object, and obviously the more the weight, the heavier the object is, the more the potential energy due to gravity is for this object. So there is something that happens in nature, which is really, really interesting, and that's the fact that there is a quantity in terms of total energy that is going to be conserved, and that's called mechanical energy. So let's see what this is. Mechanical energy is essentially combination of kinetic energy that I talked about before and gravitational potential energy. So mechanical energy, in another word, is kinetic energy plus gravitational potential energy, and this quantity, as long as there is no forces that chew up my energy, like frictional forces, air resistance and things like that, if those guys are out the window, then this quantity is conserved, which means that no matter what happens to my motion, combination of kinetic plus gravitational potential energy is going to be a conserved number. That number is held constant no matter what happens. If my surface is frictionless, or if I ignore a resistance and things like that. There is this analogy that I use all the time, and it mostly helps people to understand what it means when we say conservation of mechanical energy. And this is how I always, this is my analogy. I say, well, suppose I get out of the house and I have some money in my pocket. So suppose I start off with $100 bill in my pocket, and I go out the house and I essentially, basically let's say go to school. So here is school, and on my way to school, I start breaking this $100 bill into, smaller bills, like maybe 50-50, and then, break this to like 10 and like 2 20s and like 150 and whatnot. But at the same time, I still have the $100 in my pocket. This $100 bill is, the analogy is basically between the whole money and the whole mechanical energy. So as long as no one on your way steals the money out of your pocket and reduces the mechanical energy, you still have the same number till you get to school. But when you get to school, you have it in different form. Maybe you have it like in 50 and like at 220s and 110, or anything else. Nonetheless, total money is always $100 bill all the way till you get to school. Now, if there are some frictional forces that, they chew up your energy and all that sort of stuff, sure, you get to school most probably with the less amount of money. But in 99% of the time, our questions are all frictionless, ignore air resistance and all that sort of stuff, in which the road is safe and you're going to be having the same money but with a different format. Now, what it means in physics is that when, for example, you go from somewhere to somewhere else and, at one point, suppose this is a roller coaster track or whatever, and you are starting off here at some height with respect to the ground, and now, for example, this height is like 10 meters or so, and you're starting off with a mass of like 5 kilograms up high here from rest. So if you start from rest, your kinetic energy is dead zero, but because you're going to be having potential energy due to gravity because of your height, right? Gravitational potential energy due to gravity at this point is mgh, and that's 500 joules. Kinetic energy, because its velocity is zero, it's actually zero, and combination of these two, which gives rise to mechanical energy, is 500 plus zero, and that gives you 500 as mechanical energy. Now, if the track is frictionless, which means the road is safe and no one is going to steal anything out of my pocket, nothing from this 500 joules is going to taken off of my wallet along my way. When I get to here, I'm with some other height, I'm still having the 500 joules as my total mechanical energy, which is combination of kinetic plus gravitational potential energy. So even at this point, I'm having gravitational potential energy plus its own kinetic energy at this point, and both of them, they add up to 500 that I started off with. Now, obviously, my height here is maybe 5 meters, so this is smaller, but then this takes care of the rest so that they add up to 500, right? So if I'm now a height of 5, then I have mass g h, and that gives me 250, and kinetic energy has to take care of another 250 in order for them to make up the $500, right? Now, if I come down, let's say to here, where I'm like 1 meter above the ground, then again, I am having the same 500 joules as my mechanical energy, and that is equal to mgh, which is 5 as my mass, g10 times h. So this is gravitational potential energy plus kinetic energy. So gravitational potential energy is now 50 joules, and kinetic energy has to take care of the rest, which is like 450 joules, right? So if at any point, as you can see, I can actually recognize the kinetic energy, right? And because now I have the kinetic energies at these points, if I ever am asked about the velocity of my object, then I can solve for it, right? For example, at this point where I know that my kinetic energy turns out to be 250, I know kinetic energy, if I open it up, the ingredient is a half mv squared, right? My m is 5, so a half times 5v squared. So now at this point where my kinetic energy is 250, I have 5 over 2 v squared, and now I can very easily solve for my velocity. My velocity is actually 10 meters per second if you work it out. So you multiply it by a 2, that gives me 500, divided by 5 gives you 100, v squared is 100, so v is 10. At this point, where I know my kinetic energy is now 450 joules, now, if I ever want to know the velocity, it's a half mv squared. So 450 is a half times m times v squared. And then I can just solve for the velocity. So that gives me 900 over 5, 180 as my v squared, if you work it out. And v becomes square root of 180.